Hello, Course 3 students. We are looking at Lesson 1-5, Properties of Numbers. We want to identify the properties of numbers and use those properties to solve problems. Okay, so let's get right into our key concepts here. We have the commutative properties of addition and multiplication. Generally, remember that commutative means that order is not important. In other words, I can change the order of the numbers, the add-ins, and not change the sum, or I can change the order of the factors and not change the product. So to illustrate that with arithmetic, 7 plus 12 is the same as 12 plus 7. With multiplication, 7 times 12, is the same as 12 times 7. Algebraically, that can be represented as a plus b equals b plus a, or the product a times b is the same as the product b times a. Okay, so order does not matter in the commutative property. Commute means to move around, so that's how I remember that I can move them around and not change the sum or the product. The associative properties of multiplication and addition tell us that for each of those two operations, that grouping will not change the product or the sum. So here we go. If I have the sum 4 plus 7 plus 3, that is the same as 4 plus the sum 7 plus 3. Okay. With algebra, the quantity a plus b plus c is equal to a plus the quantity b plus c. With multiplication, the quantity 4 times 7 times 3 is equal to 4 times the quantity 7 times 3. With algebra, the quantity a times b times c is equal to a times the quantity b times c. Okay, so here again, the way in which they're grouped, the add-ins or the factors, does not change the final product or sum. Now, the identity properties. We have identity property for addition and identity property for multiplication. Basically, 6 plus 0 is the same as 0 plus 6. In either case, they both give you 6. Okay? So a plus 0 equals 0 plus a. Both of those equal a. Okay, so adding 0 to a number simply gives you that number back as your sum. Similarly, multiplying a number by 1 in any order gives you that number back. So 6 times 1 is the same as or equal to 1 times 6, which equals 6. A times 1 is equal to 1 times a, or a. Okay, so the identity for addition is adding 0. The identity for multiplication is multiplying by 1. Okay, the distributive property. The distributive property is basically telling us that the factor sitting outside of the parentheses gets distributed to each and every number within the parentheses. Usually that number is going to be a sum, but to each and every term within there. Okay, so for example, this means that 3 times the quantity 2 plus 7 is equal to 3 times 2 plus 3 times 7. Okay, I was taught to draw little rainbows to connect them to show what had to go together. Sometimes people find that helpful, but remember also the operational sign in here is what happens between the products. So you're going to have the product of 3 and 2 plus the product of 3 and 7. Okay, looking at that algebraically, a times the quantity b plus c is equal to a times b plus a times c. Again, a gets distributed to both terms within the parentheses. All right, this is a similar situation. The only thing different is that the number that we're multiplying is behind the parentheses. The process is still the same though. We're going to do, the 3 will get distributed to both the 2 and the 7. So the quantity 2 plus 7 times 3 is equal to 2 times 3 plus 7 times 3. So each term within the parentheses, 3 distributes to them, and then I add those two products together. Similarly, I could illustrate this with variables. The quantity b plus c times a is equal to the product ba plus the product ca. Again, the a being distributed to both terms within the parentheses. This also works for subtraction as well. Okay, so I could say 5 times the quantity, 8 minus 2, gives me 5 times 8 minus 5 times 2. Algebraically, a times the quantity b minus c gives me a times b minus a times c. Again, the a being distributed to each term in there. You do not have to draw these little rainbow things, but sometimes they can be a helpful visual clue as to what you need to do. Finally, the quantity 8 minus 2 times 5. That gives us 8 times 5 minus 2 times 5. Okay. Similarly, the quantity b minus c times a gives us BA minus CA. Okay, so basically the term that is being that you're multiplying by is distributed to each and every term within the parentheses in which you are adding or subtracting. Okay, those are our key concepts. Let's turn to the back side here. And actually, you might wonder, why would I want to do this? Well, sometimes what you can do with this is using some mental math so that you can use these properties to help you do some problems that go by that you don't have to do with a calculator or with pencil and paper, perhaps. Okay, so using mental math. Use mental math to simplify 13.8 plus 17 plus 6.2. What you think. So this is basically trying to point out this is what you might want to look for. Look for numbers that are easy to add. The sum of 3.8 and 6.2 is 10 because 3 and 6 is 9. 8 tenths and 2 tenths is another 1, so 9 plus 1 is 10. That should be an easy one that really any of you should be able to do. And we're left now with my third term. The sum of 10 and 17 is 27. So when I simplify 3.8 plus 17 plus 6.2, I get the sum of 27. Okay, and here we're going to go into a little greater detail as to why it works here. Okay, so basically, and again, a lot of what we're doing here and the properties that we just went through on the front page, you use those properties perhaps, or really in most cases, without really realizing that those properties have a special name. We understand them and don't always remember what their names are, but we are trying to learn those names here. Okay, so why it works. Well, the first thing is basically if you're removing or thinking about 3.8 plus 6.2, so I'm commuting the 6.2 and the 17. They're changing places. So this is an example of the commutative property of addition. Okay, notice there are M's and T's but no N's in there, okay? And then by using the mental math, I can add 3.8 plus 6.2 to get 10 plus 17, which then gives me 27. Okay, order of operations simply means I'm adding from left to right, which is why basically even though I may not write it out formally, I am commuting these two to use them, and then I have my order of operations. Okay, so that was just a quick example of using the commutative property to do a mental math problem. Now let's use the distributive property. Find the quantity D plus 23 times negative 4. Okay, so the first thing I want to do is distribute, so I'm going to use the distributive property. Okay, and my clue is that I have two operations here. I have addition and I have multiplication. Some people sometimes think that when they see parentheses, it's automatically associative. Associative occurs when it's all addition or all subtraction. Distributive property always involves two operations, addition or subtraction and multiplication or division. Okay, so in this case we have addition and multiplication. So distributing, I get D times negative 4 and 23 plus 23 times negative 4. Okay, so when I multiply negative 4 and D, that gives me negative 4D. And I do want to write the constant of negative 4 in front of the D. We don't write D negative 4. When we simplify it, it's negative 4D. And the product of 23 and negative 4, which is negative 92. Okay. Now I can go a step further and rewrite this as a subtraction expression, negative 4D minus 92. This is a little more simple if I'm trying to simplify here than having a plus a negative. Because remember, to subtract an integer, we add its opposite. So that's really applying also the definition of subtraction there. And number 3. A student buys 11 CDs. Each CD costs $6.10. What is the total cost? And here again, we're going to use some distributive property here. What we want to do is basically think of this as 11 times $6, all right, plus 10 cents, or 0.10, or just 0.1 if you'd like. But if you think of it as money, it's $6.10. So 11 times 6 and 11 times 1/10. Okay, and that was applying, again, the distributive property. When I multiply, 11 times 6 is 66. And 11 times 1/10, hopefully we know that multiplying by a tenth basically ends up moving my decimal point one place back to the left. So that gives me 1.1, or $1.10 if I want to think about it in money. So I'll put that 0 in there just to keep consistent with the money. So 66 plus $1.10 is 67.10. So the total cost here is $67.10. Again, basically this is employing how you might be able to use the distributive property, and using the distributive property sometimes can help you do some of these problems that aren't super hard, but without having to use pencil and paper or a calculator. Okay. All right. Now, before tomorrow, before you return to class, I would like you to have the quick check questions completed. Please also bring in any questions you might have, and I will probably have a few questions for you as well. Thank you.